everybody. Thank you for coming. Also considering that you're probably skipping lunch or compressing the lunchtime. So I'm so happy to be back in a live conference. So I'm really happy, and I'm not used to talk anymore. So please be a bit kind. I suppose that's quite true for everybody. But the talk today is about error handling and logging in the functional world, and we will talk about Kotlin, but that's because I'm working with Kotlin, basically. Nothing that is in this talk cannot be applied to Java or other language, even if I personally like Kotlin a lot. This talk had another cover, but I just use a IA generator to generate this cover from the name of the talk. I don't know why I decided, but I kind of like this kind of pattern, and this is what Midjourney decided that is a good match for error handling and logging in a functional world. And I wrote a book, and this talk is a bit from some material of the book. So if you are interested, you can read the book or consider to read the book to see the more complete explanation. But the important, interesting thing is why I wrote a book about functional programming. It's really full of book about functional programming. But I think there was, I'm using this stuff in production for several years, and I think there are not many books about real day-to-day using functional programming to deliver stuff. So a kind of software craftsmanship, if we want, or clean code or good TDD, how to work with the functional programming in this kind of environment day-to-day, comparing instead that there are very good books about the theory behind the functional programming. So my book is very pragmatical, very hand-to-hand, and not much theory. And the book is not out yet, but I wrote it, just completed this month. So now it's I need to add an appendix and a review. So it should be ready on paper soonish. The editor, Pragmatic Programmer, put 2 copies in. So if you tweet about this talk with Devox and my name, my handle, at the end I will random pick up 2 copies to give away if you are interested. Okay, so this talk is about error handling and exception, and there will be 3 takeaways mainly. Exceptions are overused, log levels are redundant, are not that necessary, and log static factory is not such a great idea. You may disagree, but this is my talk, so I will talk about it. But at least you know that there is a different point of view. So all of this is about bringing to you by functional programming. And whatever it is, functional programming. So the first part of the talk, we talk a bit about functional programming. And I hope not to annoy anybody, but I hope to make it a bit interesting. So what is functional programming? What do you think this stuff are? Exactly. Functional programming is a tool. It's a tool to make a job. It's not a silver bullet. It's not something that you wanted to use for yourself. I mean, you build a table using a screwdriver because you want a table. You don't build a table because you wanted to use the screwdriver. And I think this is a kind of good approach to functional programming. And how we can describe functional programming. So this is kind of, this morning, grab a page from Google about what is functional programming. And interesting, most of these definitions are not really correct, because, for example, they are mixing functional programming with declarative programming, but these are two different things. You can have a declarative object orientation. You can have imperative functional programming. They are separate things. But some of them are actually quite good. And let's have also consider some kind of typical misconception about functional programming. You know, from one side, I often have to talk with people that say, yeah, I'm doing functional programming because I use a bit of list map and lambda in my object. And that's not enough to say that you are doing functional programming. On the other side, there are people that say, oh, no, if you don't use super complicated library, specific language, or stuff like that, you don't do functional programming, which is also wrong. You can do functional programming with the Visual Basic if you want. It's just a bit, it's not a great tool. And also, some other people say, yeah, functional programming is more or less whatever you want to be, which is also not true, because functional programming, basically, is the idea, the original papers, it's an idea to try to put in code what is the lambda calculus, which is a mathematical thing to basically express algorithm mathematical with this lambda, this count. And the lambda, as in Java lambda, came from the lambda calculus. Which is also funny because actually Alonso Church, which is the author, didn't want to use a bit symbol in his manuscript, and the typographer say, we don't have this symbol, what we can use, and say, okay, we can take a Greek lambda, and that's where lambda came in. It's kind of a typo of the publisher. But functional programming is really about functions. And composing stuff with a pure function. And what's a pure function? Pure function basically is a function that has two rules. That it cannot take any input apart from its parameter. So it cannot access the file system, singleton, other static method from anywhere else. And it cannot change the state of the system in any way. So the only output is result. So if you type something, if you print something on the console, for example, that's considered a side effect because it's not the result in the function. It's something that you do without, let's say, being in the function signature. And what this is called is referential transparency, because that means that you can consider the function something that is completely transparent, and you can compose functions together and replace the function with their value, because for the same input you will always get the same value. We are a bit skimming. I'm assuming most of people probably know a bit of the stuff, but I just wanted to make it kind of plain. And if, from this point of view, a web server is just a function. It's a function that takes a request and return a response. So doing functional programming, a web server in functional programming, means that you are composing function. You are responding to request with a response, and this you do using functions. And so this is a bit from my book, but basically this idea is that each arrow is a function that, and that the names are types. So we have a request that where function will extract the user and the list name. The small application is a to-do list application. Then a second function that will extract the to-do list from the list name. The third one will transform the to-do list in an HTML page, and the fourth one will put the HTML page in a response. So it's 4 functions. And this is more or less what you translate in code. So you have extract list data, fetch list content, render HTML, and create a response. 4 functions you put together, and you have a web server. And this is, I don't know how many of you are kind of familiar with the Kotlin, like can read the Kotlin? Okay, probably 50% maybe. But it's not that different from Java. Basically, this is the 2 colon at the beginning is a reference to a function. So basically, we can write the same things that is in top with the same code that is in the commented section. It's just that if we concatenate the function, it's a bit easier to read. And this is what in the book I call thinking in morphism. So designing your application, thinking about composing functions. It's not just a matter of doing object with some transformation inside, but really thinking the whole application as a composition of function. And there is a problem. Okay, we talk about the pure function, but what about the impure one, the one that, for example, in this case, the one that goes to fetch the data from database? And this is kind of important because then when we will talk about exception and error handling, this is where basically mostly came from. So we will spend a bit of time here. And the idea of the solution of functional programming is using what is called functional effects instead of side effects. So the functions, let's say that the structure that will handle the impure things, they will use as an effect, which is kind of declared, instead of being a kind of side effect under the carpet of a function that doesn't seem to go outside, I mean, interact with the I/O. And yeah, the most, how many of you know the terms monad? Ah, okay, I thought probably 60%, I thought even more, but monads are the typical way that, the most powerful way that functional programming can handle side effects, so putting functional effects inside your functional programming. There are other ways which probably, I mean, you don't have to use monads everywhere. Monads is a bit like your last resource, your most powerful weapon, but also the one that is heaviest. So if there are shortcuts, you don't need to use monads, but sometimes you really need to use monads. Problem that monads came with a course. No, not this course, the course of the monad. And the course of the monad, how many of you know about the course of the monad? Let's do a bit. Okay, so it's good. So almost nobody. The course of the monad is that once you get the epiphany, once you understand what the monad is, you lose the ability to explain to anybody. And this is the definition by Doug Crawford. So I'm not going to explain you what is a monad, because there is a course. But I will give you 2 hints. And let's see if they are useful. So the first hint, a monad is a functor. And the functor are transformer. So probably the functor that everybody knows is the list in Java. Now can do map. And the map is a transformation. So you have a list of integer. You take a function integer to string. You get a list of string. This is because list, technical, in functional programming, list is a functor. And but it's not only list, and also the collections are a bit special because they are a collection. So it can be a bit hard to get the idea of a function, of what is a functor using a collection. But in general, functor is a some kind of data structure that is generic in one type. And when you apply a function that transforms that type, you will get a different, the data structure in the other type. By the way, that is another IO-generated image on what is transformer. I don't know. For understanding what is a functor, probably the most useful, actually, not fun, so in absolute, in my opinion, the most useful functor that exists is the context reader functor. Sometimes it's also called reader or environment. You can find the different names. But the idea is that it's a functor that wraps a function. So you have a function that goes from, in this case, ctx to t. And then if you can transform it to something else, like in ctx to u, if you give a function that goes from t to u. But in the context of handling with side effects and transforming side effect in functional effects, a functor, a context reader can access a cache, a file, a socket, a database, a thread. So you can do parallelism, you can keep a connection, you can do a lot of things using kind of variation on the concept of context reader functor. So this is the idea of functors. Since there is no course of the functor, I hope there is any question? So far, so good, maybe. Yeah, you're hungry, I know that, but so now there is this idea of a type that you can be transformed. So this was the hint number one. And this is how you can use a reader, basically. So once you define your reader, this is Kotlin, what I hope of. Basically, fun is just a static function. And the type in Kotlin is on the right side, but for the rest, more or less, I hope is kind of understandable. So basically, you have in this case, 4 functions that we define to open a database connection and read a list from the connection. And then in the page, this is how we read something from a database in functional word. So, and I put the type at each level. So first we create the context reader, and then we transform at each level until we generate the page. Then to remove the context reader, we actually execute with the run with, which was the function that is defined on the top. So basically, it's the function that we gave to the functor at the beginning. So we define exactly what we want. Then we give in this case, the database connection, and we get the result. And this is how a functor works. Everything is just a chain of transformation. And now the second hint. Can you see? Yeah. So you know what is this? Yeah. A Rubik cube. And the Rubik cube is interesting because it's something that you can, from a mathematical point of view, from an abstraction, as an abstraction, it's also a nice toy. But you can transform, you can apply some transformation, but it still remains a cube. So you can turn a face, turn another face, and you get the result. If you apply the same transformation in the opposite order, you get a different result. So this is interesting because it means that you can apply the same transformation in whatever order you want, and you get a different result. It can be also the same if the two doesn't work together. But you have always a different result with the cube. So, but you can, no, sorry. You can always compose basically your transformation. So if each turn of a face is like a transformation, like what we saw, the functor transformation, then the composition, it will always give you a cube that you can apply other transformation. And this is the second hint to understand what a monad is. Because a monad is a functor, but only functor where we can bind together all the transformation. This doesn't work for all the kind of functors, but for most of the functor practice, yes. And these are monads. I'm not going to explain more than this, but the point of a monad is this one. We have the example from before, and we wanted to read the list, but also write a list. And if we try to do basically apply a transformation to write a list, the last line, what do we get? We get a context reader inside another context reader. But by the way, sorry, context reader is something that reads the context. It's not related to the fact that it reads the database. I mean, you can read or can write the database. You can do whatever you want. But it's related to the fact that it reads the context. And so this is not good because you have a context reader inside another context reader, and you wanted to get rid of this context reader to get the result. And so you don't want to connect it twice to the database. And that's where basically this analogy with the cube works, because you can keep applying the same transformations and you still get a cube. You don't get a cube inside another cube if you want. And this is the idea of a monad, which is something with that allow you to bind together two transformation. Not simple transformation. The creation of a new context. So you have a context, and then you have this function bind, when you give a function that creates another context, but the result is not the context of a context, it's just a simple context. Does it make sense? Well, I know, it's not easy, but it's useful. The first time that I started using this stuff, it was confusing. So it's totally normal, but it's very powerful. And when you start using, it's like the Kobe cube. How can you explain this to someone that never used? It will be quite hard. But once you start using, you start seeing the benefit. And so at this point, when we have the monad, we can use the bind, and we get the result. And by the way, transform is the same that is a map in the list, and bind is what is a flat map in the list. So if you have a function that from each element of a list generate a new list, you cannot apply with a map because you will get a list of lists. You apply with a flat map. So this idea of bind is exactly the same of flat map. Now, in this specific case, basically, I'm using in the book the transform and bind to keep separate for didactic purposes from map and flat map. But is more or less the same things. And now we can go to the actual main topic of the talk, which is exceptions. And in Java we use, in Java, but also in Kotlin, we use exception to handle errors. And historically, Java had the checked exception, which are kind of out of not in fashion anymore. And why? Because it's they are quite verbose. I mean, you have to remember all the signature. And they force also to handle the result twice because we need to handle both the result of the operation, but we also have to handle the exception kind of separately using a try catch or a declaration. And also, it's not the main issue at the beginning, but it makes it very hard, as also Mario said in his talk, very hard to compose one on another. Now, the unchecked exceptions are much more useful for, much more used recently for errors. But the problem is that they break the flow unexpectedly. For example, talking about you have a log, there is an exception, the log doesn't get called, or even worse, if you open a resource, left a resource not closed, or stuff like that. Then, of course, you can use try finally, all this stuff, but it makes complicated. And sometimes you don't, I mean. And also you lose the original context. So when you have the error, you don't know exactly where, what was the context that created that error. Because you only have the exception with the line number. That can help, but sometimes it's not enough. So the idea of functional programming instead is using a monad, so how surprise, which two possible instance basically, and one is a success and the other is an error. So if it's success, it's a type of a success. And if it's an error, you can put the error. And so your code, more or less, this is a bit of pseudocode because to keep it a bit simple. Of course, in the book, everything is explained, and the code is a bit more complicated. But you can say, yeah, do your retrieve, transform, bind, and at the end, you can have either a success or a failure. And if you have a failure, you can wrap the failure. So basically, you can give more information about the failure. And okay, this is a little, the example, there are many, for example, in Java, but also in Kotlin, many libraries to do this kind of result. This is the one that I wrote, and the point that I'm using that is because we are using in production. So this is the one that I know better. And also, I wrote it, I mean, I put the repository, but it has a lot of collective wisdom from our team. So we are working several years on this stuff. So there are several little things that are quite useful. And it's part of a JSON library, but it can also be used. Okay, close. And so we wanted to have this, in the functional world, we wanted to handle the error in this way with an outcome, with an header that can be a positive result or an error result. And how this apply to logging. And how many of you know Kirk? Yeah, it is very, very good, and you should check who he is. But Kirk basically is a super senior Java developer that mostly works on solving problems and looking at the debug logs, I mean, looking at the logs to solve a problem for people. And talking about, it gave me this very, very good suggestion that you should log as much as you can when things goes wrong, but as little as you dare when things goes well. There is no point of logging a lot stuff if things goes well. I mean, the only KPI stuff that you may really need, but there is no point of saying, I'm doing well, I'm doing well, I'm doing well. What you want is that when something goes bad, you want to have the whole context, not just I'm died. No, I really want to know why, what's happened, and as much as possible. And this is where the functional programming approach works very well, because I can put all the logger that, all the information that I want in our error. So I can put, for example, in this case, what is the username? I can put for example, the HTTP request, the kind of description, the operation that I was trying to do. And then this information will only be used if something goes wrong, and they will never be used when things goes well. So it's not impacting performance. And our logger, basically, is just a function that take any outcome and a kind of a logger context, which is usually useful to know where to give more information, and just return a unit. That means return nothing happened, because it's completely a side effect. The log is something that disappears. It's not, there is no result of the log. Okay, so what about the debug statement? And the point is, when you write the debug statement, when and why you write the debug statement. Most of people, myself, I talk for myself, you write the debug statement because at some point you get something like that, an exception. And this is a real one, by the way. And you look at this exception, and you can look at the code to have some better idea, but really you have no clue what's going on. Okay, you know that at that line something exploded, but why you were there, what was trying to do. So basically, you write the debug log that say, I'm here, I'm trying to do this. I'm here, I'm trying to do this. I'm here, I'm trying to do this. Bam! Explosion. Okay, let's look at the last log of something that was still okay, and let's try to understand what happened. But with the functional way, there is no need for this, because basically when all the errors are catched, and all the errors have the full context, and when things goes well, you don't need to log the fact that they are going well until they finished. But that's at the end. So what we have is a way to work without any logger factory. We don't have logger levels because, if you want, there is errors or success. And we can also have warnings, which are kind of intermediate, but it's not really like having the log level that needed to be configured, tuned, and then log the bug and stuff like that. And there are no also configuration. But the other thing is that we log structured data. So if we have full it's not just a message, basically. We log in object that got then transformed somehow and then came up in the Splunk or the in the repository, in the observability. And the result, this is stuff that we are using in production for several years. It's really good performance because it's easy to forget log around and have some performance impact. The code is much easier to debug because usually when we have an error, we really don't it's much less the case that we have to look for why this error. The error is so explicit that you understand exactly what's happened. And much easier to test because all the errors are also easy to test because they are not directly written in the file system, but they are handled by the things. And this is the kind of errors that we have in our Splunk, basically. Something like doing this operation with this user, and also, of course, on this server, we have a lot of other information. We got this error, processing this request, which is this header, and then we can tune as much as we want. And from this kind of error, usually it's quite, of course here I remove the whole stack trace, but we also have the stack trace. It's quite easy to understand exactly why something went wrong and directly operate without having to think about I needed to add the debug statement or not the debug statement. So can we do this better? Okay, we have a few minutes. So it's just the last step to go even better than so far is to separate the domain from the technical layer, which is something that is called post-adapter architecture. And is an architecture typically from object orientation, but it works also very well from a functional point of view. And when you use this kind of approach, you don't need to have a log. Usually, you can have an exception, but let's say usually, you don't need to have a log in the domain itself, because all the errors happen around in the adapter when you accept the database, when you send a request, stuff like that. So a request came in, you process the request. At the end, there is an error. So you can log the error, but you don't need to log the error in the domain. You log the error when you are going to get the answer. And I mean, this is something that really we started recently to refactor our code base to remove all the logs from domain. And there was just a few cases, basically where we have warnings. Warnings like we are in a bank, so we process trades. And there was some case, for example, that we have 0 trades. And 0 trades is not an error, but it's strange. So we wanted to have a warning when something we say that, okay, for this day there is 0 trades. But we used to have a log in the domain, but actually looking around, it's much better if we put the log, the warning, when we get the trade, so in the database layer or in the external service layer. So if when it's a kind of defending yourself, defending the domain from wrong data, and you put the warnings on the outside. So there is, well, at least we didn't think any real case to have the log in the domain itself. And so, concluding the talk, having putting all the logger outside the domain also simplify things because it's easier to have a consistency. Sometimes there was, for example, the same event logged twice, or you forget some errors. I mean, the errors usually get logged, but some success didn't get logged correctly, stuff like that. Instead, if you put the logger in the external API, you can put it in a single point, and you are sure to get all the possible errors. And it's also much easier to test, because in this way, basically, you can simulate a test with some error cases, and you can verify that this is your result. Okay, thank you very much for the talk. I hope you find it useful. And something to think about. I think functional programming, as I said at the beginning, is really a tool. It's really something that helps you. I try in this talk to show some practical concern, not theoretical purity, which, I mean, we are paid to solve actual issue for. And for me, some kind of problems, functional programming works very well. And especially for web server, where we have a request in response, functional programming for me is really the best tool available. If someone, the book is not ready, but when if someone tweeted about this, I will, okay, we don't have much time. I will check later. I will use random.org to get the winner, and I will If you tweet me, I will tweet who is the winner. If you want, otherwise I will go to the next one. Yeah, thank you very much. I'm also around, so.